Hey everyone, welcome to Code World, and today we'll be going over another problem from the Blind 75 list, which is LeetCode number 217, contains duplicate. So in this problem, we're given an array integer of nums, and we want to return true if any of the numbers in this array appears twice. Otherwise, we want to return false. So there are two examples given with the LeetCode problem. We have a nums array in this first example, and it is comprised of four numbers, a 1, a 2, a 3, and another 1. Because there are two ones in this example, namely here at index 0 and at the last index, we return true because there are two duplicates in this case. However, in the second example, where we have another nums array comprised of four numbers, 1, 2, 3, and 4, there are no duplicates, and so we return false. So I have redrawn this example over here to the right, and we see that we have our nums array with 1, 2, 3, and 1. So I will first be going over a least efficient method of solving this problem, which will take an n-square time complexity. And afterwards, I'll show you guys how to optimize this solution. So in this case, for a more brute force approach, the first thing that might come to mind is to compare every number with every other number inside the nums array. And in doing so, we will be able to obtain every combination of numbers, every duo, and see if this pair of numbers contains any identical numbers. So we start off with the first element, which is 1. Right, so we look at our 1, and then we go and compare with every other number to see if there is another identical number, if there is another 1. So we would compare our 1 to our 2, our 1 to the 3, and our 1 to the other one at the last index. And in this case, we would see that these two ones are identical, and so we would return true. Now, if we had not found any identical pair, then we would move on to the next number, say the 2, and then we would need to compare the 2 to every number after it as well. So we would compare the 2 to the 3, the 2 to the last one. And finally, when looking at the 3, we would also need to compare it to every number coming after it, so we would compare the 3 to the 1. And whenever we achieve the first identical pair, which we achieved in this case with the 1s, we would return true. Otherwise, if we reach the end, we would return false. So here is the code for this. We see that we have two for loops, one outer for loop and one inner for loop. And because of this, the time complexity will be O of n squared. Now, space complexity, because we aren't using any extra data structures, will remain constant, O of 1. I'm going to show you now how we can optimize this approach a little bit, and that approach involves sorting. So we would have our nums array, and we would resort it based on ascending order. So we know that the 1 would come first, followed by the second one, a 2, and a 3. Now that the elements are sorted, we know that if there are any two identical numbers in the array, they will be right next to each other. They will be placed subsequently. So what we can do now is just simply go through the nums array once, and then see if there are any identical elements next to it. So we would start off with the first element in the array, so the 1. And all we have to do is compare it to the next element and see if there is an identical element. And of course, we'd see in this case that the 1 is the same as 1, so we can return true. Now, if we had not found an identical element, we would move on to the next number. So we would move on to the second index, and we would compare it to the next number. And we would see that these are not the same, and then we do the same for the last element. So this would require only one traversal. However, because of the sorting algorithm, we know that sorting takes n log n time, so our time complexity would be O of n log n overall. Our space complexity remains constant. So here's our coding solution in Python for our second approach, which is now more optimal compared to our first because we have an n log n time complexity rather than a quadratic time complexity. We see that the code starts out with a sorts method. So we know that this method in Python takes n log n time, and sorting cannot be achieved in a better than n log n time complexity. Afterwards, we have a for loop, which takes a linear time complexity. However, because we already have a method which takes n log n time, this will remain our overall time complexity. Now I'm going to show you guys a third most optimal approach, which uses a bit more extra space in order to achieve a linear time complexity. So we have again here our nums array 1, 2, 3, 1 in non-sorted order. So we do not use any sorting in this algorithm. And what we instead we do use is a hash set. Now a hash set is a data structure which allows us to store values in an unordered fashion. And then it allows us to look up these values and check to see if we contain specific values in constant time. So what we would do in this case is we would traverse our nums array only one time. And after traversing our array, each time when looking at an element, we would check to see if our nums array is in our hash set. If it is, we would return true because we have a duplicate value. If not, we would add the number to our hash set and then continue on with our algorithm. So we would start off with our 1. And when looking at the 1, we check to see if there are any 1s in our hash set. We see there are no 1s in our hash set. So what we do is we add the 1 to our hash set, and we continue on with our algorithm. So we move on to the 2. Once again, we check to see if there are any 2s in our hash set. There are no 2s in our hash set. So what we do is we go on and add the 2 to our hash set. Subsequently, we look at the 3, and we check to see if there are any 3s in our hash set. Once again, there are no 3s in our hash set. So what we do is we simply add the 3 to our hash set. And finally, we check for the final 1. So we encounter another 1, and we check to see if there is a 1 in our hash set. So we see instead that in this case, we have a 1 in our hash set. So there is no longer need to continue in our algorithm. We have found a 1, which means we found a number which we have previously encountered in our nums array. So we found a duplicate. And in this case, we can return true. If we reach the end of the nums array and we do not have any duplicates, then instead we would return false. Now in this case, we've noticed that we've only traversed our array once and looked at every element once. So this means we have a linear O of n time complexity. However, because we are using a hash set, an additional data structure, which can contain all of the elements of our nums array, we're using linear space complexity. Overall, this is the most optimal approach out of the 3 we've seen because we have the linear time complexity. So if we are prioritizing time, then this is definitely the most optimal approach. However, if we are prioritizing space, then this may not be the most optimal approach. Okay, so now that we've seen the best approach, we're ready to code it up in LeetCode. Okay, so we're here back in LeetCode, and this solution is going to be pretty quick to type up. So what we said first of all is that we wanted to create a hash set. So that's going to be our first step. So all we have to do is we can create a set. We will call it hash set, and it's going to be an empty set initially. And then for each number in our nums array, what we want to do is check to see if num is in our hash set. So if the number is not in hash set, what we wanted to do is add the number to our hash set. Otherwise, if our number was already in the hash set, we knew that we wanted to return true because that means we found a duplicate value. Finally, if we finish the whole array and we go through the entire array through our for loop and we don't encounter any duplicates, we want to simply return false because that means there are no duplicates. So this is the entire code. Let's check to see if it runs, and we can submit it. And we see that it works and it's very efficient. So thank you so much for watching this video. I hope you found it helpful. If you liked it, please subscribe to my channel and I'll see you in the next one.